Hi guys, in this tutorial, I'm gonna solve question number 4, Jan 19. A boy sees a box on the end Q of the plank PQ, which overhangs a swimming pool. The plank has mass 30 kilogram, is 5 meter long, and rests in a horizontal position on 2 brakes. The brakes are modeled as a smooth support, there is no friction force. One acting on the rod at P and one acting on the rod at R, whereas PR is equal to 3 meters. The support at R is on the edge of the swimming pool as shown figure 2. The boy has mass 40 kilogram and the box has mass 2.5 kilogram. The plank is modeled as a uniform rod and the boy and the box are modeled as particles. The boy steps on the plank at P and begins to walk slowly along the plank towards the box. Find the distance he can walk along the plank from P before the plank starts to tilt. First, the boy starts to move from this position. Move slowly till the rod started to tilt. So when the boy move till R, nothing happened. But when it is passing the point R, the particle, the rod started to tilt, means if the boy at this position. So its weight acting down will be 40 G. And the mass of box is 2.2 G. Start to tilt means remove the normal reaction at this point, will be 0 at this time. So he asked to get the distance now from the boy to the point P. Ask name this part is X distance. So the uniform rod means the weight acting in the middle. So 1.5, sorry, it's 5 divided by 2, 2.5 meter. And its weight is, it's written here, the rod, its mass is the mass of the boy. And the mass of the plank is 30, so the weight is 30 G. When we try to get the moment at P, moment at P is equal to 0. So 30, we have 3 right side and only 1 left side, clockwise or anti-clockwise, where is the normal reaction at R. So we can find the normal reaction first, then find the moment at P, or you can directly find the moment at R. You can find the normal reaction at R by adding 30, 40, 2.5. This is 5, 2.5. You can find this value by adding 30, 40 will be 72.5 G. If we try now to get moment around the P, we have 3 clockwise and only 1 anti-clockwise. We'll start first with clockwise, 30 G, 30 G times its distance, 2.5, and 40 G, and its distance is X, and 2.5 G and the distance is 5, is equal 72.5 times G times 3. The distance is 3. From this equation, you can find the value of X. When we remove divided all by G, so you can find the X 3 times 72.5 minus 2.5 times 5 minus 30 times 2.5 then divided by 30 by 40. So the answer is 3.25 meter. Or without finding R, if you apply the moment at R is equal to 0, this is another method. Moment around R is equal to 0. So we have 2 clockwise, see 2.5 rotate clockwise, and 40 clockwise, and 30 anti-clockwise. You can find 30 will be anti-clockwise. So when you apply the moment at R will be 0, 2.5 G, 2.5 G multiplied by the distance, which is the remainder from 5 will be 3, sorry, it's 2. So times 2 plus moment of 40 will be 40 G times the distance. We can write this distance is 3, and this part will name it only Y. Let's say this part is Y. So 40 G times Y, 40 G times Y is equal to the anti-clockwise, which is 30 G times the distance, 30 G. If this distance is 2 and this distance is 3, so add 2.5 to this part, only 0.5 will be 0.5. From this equation, you can find the value of Y divided by G will be 30 multiplied by 0.5 minus 2.5 times 2 divided by 40. This value Y will be 30 times 0.5 minus 2.5 multiplied by 2 whole divided by 40. So the final answer is 0.25. But he asked to get the distance from the point P. So this part is 0.25 plus 3. So the total distance will be 3.25. Same answer by the first method. Second part B, state how you have used in your working the fact that the box is modeled as a particle. When I say what is the difference between the modeled as a particle means when I say this part is a particle means the center, the mass at the center. So when we use this as a box, but it's written as a particle, so I will use its mass at the point Q. So when we use any shape, this box, the boy as a particle means its mass acting at the point of Q. In part C, a rock of mass m kilogram is placed on the plank at P. I will start to show the other figure to show the forces. I will use it again. In part C, a rock of mass m kilogram is placed on the plank at P. So now we'll have a mass, so will be mg weight acting at P. A rock of mass m kilogram is placed on the plank at P. The boy is then able to walk slowly along the plank to the box at the end of Q. Now, the box still here, so its weight 2.5 kilogram, but also the boy is same, so acting down, which is 40, will be 40 G, both at the same point. A rock of mass m kilogram is placed on the plank at P. The boy is then able to walk slowly along the plank to the box at the end Q without the plank tilting. The rock is modeled as a particle. Find the smallest possible value of M. So now, without tilting, the system in equilibrium, we have here weight mg. We still have the weight of the rod in the middle, which is 30 kilogram, act at 2.5. And still we have here a normal reaction at point R. If we try, he asked to get the minimum value, or asked to get in part C, find the smallest possible value of M. If we try again now to get the moment at R is equal to 0, we have this part clockwise and this part anti-clockwise, this part anti-clockwise. So the clockwise is equal anti-clockwise. So we'll add 40 and the 2.5 will be 42.5 G multiplied by the distance, which is 2. The anti-clockwise is 30 times G multiplied by 0.5 multiplied by 0.5 plus mg multiplied by 3. By solving this equation, we can divide it by g. So m is equal 42.5 multiplied by 2 minus 30 times 0.5 multiplied by 3. By calculating the value of m, 42.5 multiplied by 2 minus 30 times 0.5 all divided by 3. So the final answer is 70 over 3. Mass is 70 over 3, or you can write it as a decimal, 23.3 kilogram. So the final answer. Thank you.